Hello my dear viewers and also my dear students, welcome to today's lesson. We are going to learn types of numbers, and basically in this tutorial we shall learn about odd numbers, even numbers, square numbers, cubic numbers, prime numbers and composite numbers. So kindly, if you're doing anything, just pay attention for this particular moment and you're going to learn more about this. Now we begin with the first one, which is odd numbers, and we say that odd numbers is a number ending with digit 1, 3, 5, 7 and 9. So for our case here, we have the first column whereby we have these numbers. So we have 11, 21, 31, all of these number, they are ending with 1. So they are ending with digit 1. Also, we have column 3, numbers ending with digit 3. So all of these numbers, they are odd numbers. They are ending with digit 3. So I've basically choose to deal with numbers from 1 all the way to 100 based on all these numbers so that we can understand better. Then we also have numbers ending with the digit 5. So in column 5 we have these numbers ending with digit 5. All of them are odd numbers. So that is very, very important. And then we have the other one ending with digit 7. So we have column 7. All of these numbers are ending with digit 7. So they are also odd numbers. Then numbers ending with digit 9. So we have in column 9, so we have these numbers ending with digit 9, so they are all odd numbers between 1 and 100. So if you see all those numbers, so provided a number ends with 1, 3, 5, 7 and 9, then it's an odd number. So that is all about odd numbers. So we are going to move on to the next one, which is even number, and we say that for even numbers, they end with numbers ending with the digit 2, ending with digit 4, ending with digit 6, 8 and 0. So in this table, we shall look at numbers which end with the digit 2. So in column 2, we have all of these numbers ending with digit 2. So they are even numbers. Then we also have numbers ending with the digit 4. So in column 4, we have these numbers that end with digit 4. They are all even numbers. Then we have numbers ending with digit 6. So in column 6 we have numbers that end with digit 6. They are all even numbers. Then number ending with digit 8. So we have 8, 18, 28, 38, 48, 58, 68, 78, 88 and 98. So this number are even number. And lastly, numbers that end with 0. So we have the last column, column 10. So these numbers ending with 0, they are all even numbers. So for you to know an even number, we basically have to know which digits does the number end with. So all of those digits that I've circled, they are even numbers. So we shall move on and look at the next type of number, which is square number. For square number, I want us to understand this. We know that natural numbers start all the way from 1 to an infinite, and let me just write some of the natural numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and square numbers can be formed by squaring or multiplying two natural numbers. So if we multiply two natural numbers, we get square numbers. So if we multiply each of them by itself, that will be 2 times 2, we get 4 times 3, we multiply each of the natural number by itself. So we get 9 times 4, again this, we get 16, 5 times 5 is 25, then 6 times 6 is 36, 7 times 7 is 49, 8 times 8 we get 64, and 9 times 9 we get 81, 10 times 10 we get 100. So these values that we have to the right, so this is the one which forms what? This is the one which forms the square number. So that is what now we have, and therefore we are going to circle it. So we have the first square number, which is 1. So 1 is a square number. 4 is also a square number, so we have 4 is a square number. 9 is another square number, so we circle it. We have 16 is a square number, have it here. We have 25, a square number, so we have it here. Then we have 36, which is a square number, we have it here. Then we have 49, which is a square number, so we have it here. Then 64 is a square number, we have it here. Then 81, which is a square number, so we have it here. And lastly 100, which is also a square number. So those are the square numbers between 1 and 100. So whatever I've circled, those are the square number. So if you have numbers beyond 100, say 11 times 11, you get 121. 121 becomes a square number, and so on. So believe that is okay to all my viewers. So allow me, we move to the next one. Next one, which is cubic numbers. For cubic numbers, we say that they can be formed by multiplying natural numbers 3 times. You multiply the natural numbers 3 times. So for this case, we can have the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, in other words, we cube or we multiply 3 times. So if this we multiply 3 times, which is 1 times 1 times 1, it is 1. The other one is 2 times 2 times 2, we get, that is 8. 3 times 3 times 3, we get 27. 4 times 4 times 4, we get 64. 5 times 5 times 5, we get 125. 6 cubed, we end up getting 216. 7 cubed, we end up getting 343. 8 cubed, we end up getting 512. 9 cubed, we end up getting 729, and 10 cubed, we get 1000. But for our case, we are dealing with number between 1 and 100. So In this case, we have the first 4, and you can be able, so 1 is a cubic number, 8 is another cubic number, 27 is another cubic number, 64 is another cubic number. So those are the cubic number between 1 and 100. But the list can extend if you find numbers beyond 100. Fine. Most important thing, let us now look at prime numbers. Prime numbers. And we are saying that prime numbers are numbers divisible by 1 and itself. Number divisible by 1 and itself. So I'm going to consider row by row, and we get to list some of the prime numbers that is only divisible by 1 and itself. So that is very key. Now, let us look at the row number 1. So 1 is not a prime number, because at least it must have 2 factors, 1 and itself. So 2 is actually a prime number since it is 2 times itself. So also 3 is a prime number, 4 is not, 5 is a prime number. We also have 7 as a prime number, 8, 9, 10, those are not prime numbers. In row 2, we have 11 is a prime number, 12 is not, 13 is a prime number. Then we have 17 is a prime number, 19 is also another prime number. In row 3, 23 is a prime number. Then we have 29 is a prime number. In row 4, we have 31, the only prime number, and 37 is a prime number. The others, they are not prime numbers because they are more than 2 factors, and not only 1 and itself but more. Then row 5, we have 41, we have 43, we also have 47. Then in row 6, we have 53, then we have also 59. 57 is not a prime number, so we have 53, 59. Then in row 7, we have 61 and 67. In row number 8, we have 71, it's a prime number. We also have 73, it's another prime number. And then 79 is another prime number. Row 9, we have 83 as prime number, and 89 is prime number. Then the last row, we have 91, it's a prime number, and also 97 is a prime number. So if you count all of these numbers between 1 and 100, they are actually 26. There are 26 prime numbers between 1 and 100. So we are saying it must be divisible by 1 and itself. So using these prime numbers, it will help us so much in finding the other number, which is composite number. Composite number. So let us look at composite numbers. And composite numbers, we are saying that numbers written in terms of prime factors. numbers written in terms of prime factors. Already we know the prime factors. So the prime numbers that we noted, we have 2, 3, 5, 7, 11, 13, 17, 19, you have 23, then you have 29, you have 31, then 37, you have 41, you have 43, you have 47, we have 53, we have 59, then we have 61, we have 67, we have 71, 73, 79, then we have 83, we have 89, we have 91, and finally 97. Those that have circled, they are prime numbers, and therefore we need to find composite numbers that are actually written in terms of prime factors. So we are going to look at a few of them, and we shall begin the first one. So 1 is not actually a composite number, since cannot be written in terms of prime factors, and 1 is also not a prime number. So we have 2. So 2 is already a prime number. So we want numbers like, say, 4. Here we have 4. How can 4 be written? 4 in terms of prime number, 4 is the same as 2 times 2, which is 2 squared. And here we can be able to see that 2 is a prime number. So we have written 4 in terms of prime factor, 2 squared. So 4 is a composite number. Then we have the other one, the other prime, we have 6. What about 6? 6 can be written as 2 times 3. And you notice here that 2 is a prime number and also 3 is a prime number. So 6 is a composite number, since we have been able to write it in terms of prime factor. We are going to have another example still under this. We can have 8. It's a composite number, simply because 8 can also be written as 2 times 2 times 2, which is equal to 2 cubed. But 2 cubed, but 2 is what? It is a prime. It is a prime number. So 8 is a composite number. We can also still have another example. We have 9. 9 is also a composite number, since it can also be written as 3 times 3, which is 3 squared. But in our case here, 3 is a prime number. We can have 10. I'll just pick a few. We have 10. 10 can be written as 2 times 5. 2 is a prime number, 5 is also a prime number. The same case can apply to the rest. We have 12. We have 12 can be written as 2 times 2 times 3, which is 2 squared times 3. And for this case, 2 is prime, 3 is prime. So I'm going to pick some other numbers like say 66, but the rest can be expressed in terms of prime numbers. So let me pick 66. 66 can be written, yes, it is divisible by 2. Here 33 is divisible by 3 in times. So for this case, 2 is prime, 3 is prime, 11 is prime. So that's how we write composite numbers. So whatever you are going to write must have these values 2, 3, 5, 7, 11, because they are in their simplest form. Only the other factor is 1 and itself. So that's how you will be able to identify composite numbers and write them all, even for numbers beyond 100. So my dear viewers, my dear students, thank you so much for listening. If you haven't subscribed, kindly support my channel by subscribing. Thank you so much. We shall meet in our next lesson. Thank you.